Today we're going to start our chemical journey by looking at the very smallest units of matter, the atoms. What you can see here is a schematic representation of an atom. The atom is composed of three types of subatomic particles: protons, neutrons, and electrons. The core of the atom is positively charged, and it consists of protons and neutrons, which are shown here as red and blue spheres. Protons are positively charged, while neutrons have no charge. The nucleus of the atom is surrounded by this electron cloud. The electrons are shown in green. Because the number of protons found in the nucleus is the same as the number of electrons surrounding it, the total charge of an atom is neutral. The number of protons in the nucleus is called the atomic number. It determines what kind of element the atom is, for example, gold, hydrogen, or oxygen. The number of electrons of an atom is equal to the number of protons, but the number of neutrons in the nucleus can vary. The mass number is defined as the total number of protons and neutrons in an atom. When the atom gains or loses some of its outer shell electrons, we call it an ion. An ion is an atom or molecule with a positive or negative electrical charge. It has this charge because the number of electrons no longer equal the number of protons in the atom. If an atom loses an outer shell electron, the number of positively charged protons in the nucleus will be larger than the number of negatively charged electrons. The atom then has an overall positive charge. We call this a cation. On the other hand, if the atom gains one or more outer shell electrons, it becomes overall negatively charged. An atom with an overall negative charge is called an anion. By the way, this outer shell from which the electrons are gained or lost is also called the valence shell, and the electrons in it are called valence electrons. In total, humanity has discovered already 118 different elements. And all of these elements have been ordered in what we call the periodic table, which you can see on the slide here. The periodic table is very useful to chemists, as it can quickly tell you something about an element's atomic mass or some of its chemical properties. In the offices and laboratories of chemists, you will for sure find a periodic table hanging somewhere. The place of an element on the periodic table gives quite some information about that element. For example, every column of the periodic table, which we call a group, shows elements with similar chemical properties. There are in total 18 groups on the periodic table. The horizontal rows in the periodic table are called periods. There are 7 of them in total, and each element in one period has the same number of principal energy levels, or electron shells. Now let's take a look at how atoms group together to make molecules. For example, the oxygen molecule consists of 2 oxygen atoms bound together. Other molecules you probably know, like water and carbon dioxide, are also composed of multiple atoms. These different molecules can be described using their molecular formula, like O2 and H2O. The structural formula of molecules shows you how the different atoms are bound together. The Lewis structure shows you how the electrons are shared and arranged around the different atoms in a molecule. We'll now take a look at how we can draw the Lewis structure of water. For this, we need to keep the octet rule in mind, which tells us that an atom prefers to have 8 electrons in the valence, or outer shell, except for hydrogen, which prefers only 2 electrons. To draw this Lewis structure, we first count the number of valence electrons. In this case, 1 per hydrogen atom and 6 for oxygen, so 8 in total. Then we draw dots for the valence electrons that are shared. Each hydrogen atom shares 1 electron with oxygen, and the oxygen atom also shares 1 with each hydrogen atom. The atoms are now bound with a single bond. Next, we need to complete these octets with the remaining electrons. In this case, we had 8 minus 4 is 4 electrons left, and they all go around the oxygen atom. One line represents a single bond between atoms, so now our Lewis structure for water is finished. In the same way, we can also draw the Lewis structure for carbon dioxide. At step 3, you see that the octet for the central carbon atom is not yet filled. More bonds need to be formed until each of the atoms have a filled octet. That results in this case in a double bond between the carbon and oxygen atoms. There are 2 main types of bonds a molecule can make: ionic and covalent bonds. What type of bond an atom makes depends on its electronegativity, which tells you how likely an atom is to attract a bonding pair of electrons. Atoms with the same or similar electronegativity form covalent bonds. If electrons have the exact same electronegativity, we call the bond a nonpolar covalent bond. Electrons with a slightly different electronegativity do not share the electrons equally and form polar covalent bonds. When the valence electrons are completely transferred from one atom to the other, we talk about ionic bonds. These types of bonds are made between an electron donor and an electron acceptor, like sodium and chloride in this example. And with that, we've already come to the end of the first lecture. I hope you have enjoyed this brief intro into atoms and molecules.